All right, number 15, integral tangent x. You know that derivative, tangent x derivative secant square by x. You know that secant square by x integration is what? Tangent x plus x, right? Because now tangent x is antiderivative of secant square by x. But now we have tangent x, a little different, right? Tangent x is antiderivative. What is that? So tangent x can be solved this way. Change the form. Tangent x is what? Sine x over cosine x, right? We start the problem here. That's right. So use substitutions. Okay, take u is cosine x, and take derivative each side. Du equals what is that? Negative sine x, cosine x derivative negative sine x and dx. Now you got what sine x dx in there. But this sine x dx actually I'm gonna write down. Sine x dx whole thing is what? Put this number negative the other side. Negative du. Okay. So we have a sine x dx that is replaced with negative du. But this is u, right? Okay, now this one, just number u there. U over sine x dx is negative du. I'm going to put negative outside the du. Okay, just as simple, right? 1 over u du is natural log u. Okay, natural ln u, right? Yeah, not log. This one is what? ln absolute value of u n plus c. Okay. Now we replace with u is your cosine x. Negative ln absolute value of cosine x n plus c. So we don't have this one. So we're gonna change the form a little different way. This negative sign is what? Put up your negative 1 there, okay? So that is equals to ln negative 1 is what? 1 over cosine x absolute value, okay?
Okay.
Right. But this one is what is the same as this one. 1 is positive. You can put in there cosine x, same things. Are you okay with this? All right. So 1 over cosine x is what is that? Secant x, right? So secant x n plus is that okay? Yeah. The reciprocal cosine is secant x. So we have the answer choice E there, okay? Okay with this?
Yeah.
Okay, just try to solve by yourself, okay? I'm gonna hold this recording, okay? I'll give you a minute just to figure out this one because this is very popular questions, okay? Okay, go ahead. At the line 3x minus y plus k equals 0, where k is a constant and is tangent to the graph of y equals x squared minus 3x plus 5. What is the value of k? This is the linear, it is the line equations. The other one is a curve. If you have the curve over here, this is the linear line.
Yeah.
This is the graph of this one. Line is a graph over here. I'm going to express y equals, okay? Because we need the slope. Y equals 3x plus k. Are you okay with this? Move to the right, y is a positive y still 3x plus k. This is y equals 3x plus k. From here, slope of this line is what? Is the slope of this line is 3, right? So to find the equation of what is the value of k, right? We're gonna find the value of k. So anyway, we need to find the point over here, okay? We need to find the point. How can you find the point? If you find point, put this number x and y coordinate in the equations, we'll get the value of k. That's right? Because what this is the linear equation. If a point over here, that is the p, x1, y1, put this number x and y1 in the equations, you will get the value of k. That's right. Our goal is we need to find the value of point. How can you find the value of point? At this point, the slope is 3, right?
Yeah.
At this point, the slope is 3. I'm going to use this as okay, x coordinate a. Okay? F prime a equals to 3, isn't it?
Yeah.
The derivative of this one at x equal a, that is equal to this slope, 3. Okay, now put this number x prime there. F prime x is how much? 2x.
Yeah.
And the minus 3x derivative is negative 3. Okay? But we're going to find the value of a, which is what slope is 3 over here. Okay?
Mm.
So 2x equals plus 3 is 2x equals 6 divided by 2, x equals 3. That is the value of what? A, okay? A equals 3. So this value of a equals to 3. Now where is y? Put this number 3 in the original equation, okay? Original equations will get the value of y, okay? Put this number k there. F over 3, check it out. This one, okay? This is f of x. Put this number 3 there. 3 squared is 9, and minus 3 times 3 is 9, and plus 5. This is 5. So y coordinate 5. We just got our x and y coordinate from this quadratic equations. Now the next turn is what? Linear equations. Because this point is still on this line there. This point is still on this linear line, 3 and 5. So this is the solution, right, of these equations. Put this number x and y in the equation, that's gonna be equal. Y is 5, x equal to 3 there. 3 times 3 is 9 plus k. From here you can find, okay, minus 9, okay? So k equals how much? Negative 4, right? So that's the answer. Number 16. Is it okay? So I'm gonna hold the recording. You just figure out the number 16 by yourself, okay? Okay. The next one, number 17. X times cosine square of y equals to 1. Evaluate the derivative at x equals 2 and pi over 3. So dy dx. Maybe they might need both two numbers. At x equals 2, y equals pi over 3. Okay? But this is a mixed up, right? So we have to use implicit differentiation. That's right. So first one derivative is 1, x prime is 1, times second one is cosine square of y.
Yeah.
Plus, first one don't touch. The next one is second prime is what? This chain rule. 2 move to the front is what? 2 cosine y. That's right. 2 minus 1 is 1y, okay? That is 2 cosine y. After that, what is that? This is about the cosine. The next one is what? The derivative of cosine is negative sine y, isn't it? Don't forget this one, okay? We just take a derivative of cosine y, but it's a derivative of cosine y again, that is negative sine y. After that, going into the y there, that's the last one. Y prime again, you multiply y prime again. That is equals to the prime of derivative of what constant is 0, okay? So this is a cosine square of y. I'm going to move it all the other side, okay? Equals x times minus is, when you move the other side, that is a positive, right? So 2 times x cosine y and sine y and y prime. Are you okay with this?
Yeah.
After that, to get the y prime is dy dx. You can divide by this one all together, right? 2x cosine y, and sine y, isn't it?
Yeah.
That is y prime. I'm going to write prime d here. dy dx. Then we may a little simplify it because the cosine x, cosine y can common factor. So just cosine y is out. So 2x cosine 1 is out, 2x sine y. Okay? Now we need the two variable y there, okay? So x equals 2, y equals pi over 3. Put this number in there, okay? That is derivative at this point. Cosine y is what? Cosine pi over 3. 2 times 2, x is 2 is 4. I'm going to write down 4 over here. And sine pi over 3. Cosine pi over 3 is, this is just pi over 3 is what? This is 180 degree divided by 360 degree, okay? That is a cosine pi over 3. Okay? That's a special triangle. So this is 2, 1, square root 3, okay?
Okay.
So cosine pi over 3 is 1 over 2. 4 times sine pi over 3, opposite over hypotenuse. Radical 3 over 2. Okay? So this one is what? 1 over 2 over 4 rad 3 over 2. Okay?
Oh.
But this is the same common denominator cancelled out. 1 over 4 rad 3, okay? 1 over 4 rad 3, we don't have this one, so rationalize, because we have a irrational denominator. To make it rationalize, we multiply square root 3, okay? That is what? Square root 3 over rad 3 is 3 times 4 is what? 12. So rad square root 3 over 12 is the answer, okay? Choice A is the answer. Are you okay with this?
Yeah.
Okay. I'm going to hold the recording, try to figure out, okay? The position of a particle moving in the xy plane is given by the parametric equations. X equals t cubed over 3 and y equals given by here, and what is the equation of the line tangent to the graph? Okay, y equals f of x. At t equal 2. And we have a right parametric equation, not x and y, okay? So x is a function of t cubed over 3. And the y equals function of t again. So we can eliminate the parameter. This is t is called what? Parameter. Parameter is a connect with x and y with variable t. Okay, with variable t over here, we connect with x and y. We can go directly, okay? But it's hard to get with direct relation. Y equals f of x. It's hard. That's why we have to use still parameter. Because take it over here. dy dx, okay, we need to solve this one, okay? dy dx. Okay, at t equal 2 is where is the point? When t is 2, where is the point? Our aim is what? Where is the point? Tangent point.
Yeah.
And at this point, what's the slope? Which is a derivative, right? So f prime when t is 2, this is the value of t, not the x, okay? Slope of tangent. So dy dx, this is actually same, it is you can divide it by dt both sides. dy dt over dx dt. Same thing, right? Okay, you can divide it by dt both sides. So dy dx is exactly equal to dy over dx dt and over dx dt. Okay.
Yeah.
So dy dt can be obtained from here. Take out dy dt. I'm going to delete this one. dy dt. This one equals actually this is what? T cube over t is what? A little simplified. T square and 4 over t is what? 4 to the negative t to the negative 1, right?
Yeah.
So derivative of t square is 2t. Derivative next one is what? Negative 1 move down. That is a positive 4 but t to the negative 2, right?
Yeah.
This is exactly equals to what? 2t plus 4 over t squared. What about dx dt? Dx dt is what? 3 move down. 3 times 1/3 is what? 1. That is equals to what? T squared. That is the dx dt is t squared. Now put this number into this equation over here. dy dt is what is that? 2t plus 4 over t squared. Over dx dt is what? T squared. Okay, that is dy dx with in terms of t. Okay. Now from here we get the value of dy dx because t is given by here. At time t equals 2, isn't it?
Yeah.
Put this number 2 there. We don't have to simplify, right? We just evaluate. 2 times 2 is 4. 4 over 2 square is what? 1, right? 4 over 4 is
Yeah.
1.
Mm.
And t square is 4. That is 5 over 4. That's the slope. At this point, t equal to. Slope is 5 over 4. But we need to find a point. When x is 2, what is the x? When x is 2, what is the y? We need a point. This one is by x and y point, okay? Not t. So from here, when x is time 2, what is the value of x? Put this number into the here, right?
Yeah.
So x equals, when t is 2, so x over 2, right? T is 2. X of t is 2. How much? T cube, 2 cube is 8. 8 over 3, right?
Mm.
What about y? Y, x is 2. How much? From here. 2 cube is 8. Minus 4
over 2.
over
So 2.
2, right?
2.
That is 2.
Yeah.
Okay, that's the point. This is the point. 8 over 3 and y equals 2. Now we got the slope and a point already. Now we can use this point to slope. So y minus y2 is 2. Slope is 5 over 4. X minus x1 is 8 over 3. Okay? We can leave it this way. That's the answer. So which one is y minus 5 over 4? Y minus 5 over 4, x minus 8 over 3. Choice C is the answer, okay?
Yeah.
So I'll give you a minute, okay? Figure out this one, okay? I'm going to hold the recording. The graph of function f shown above. This is the graph of function y equal f of x graph.
Yeah.
So we have a new function g of x. This one is we have seen the same kind of questions a lot, right? G of x, where the area function, area can be calculated from this point. Okay, calculate. Find the equation of the line tangent to the graph at x equal 2. Okay, the graph of g. Suppose if the graph of g over here, x is 2 over here. We have tangent line. You're going to find this tangent line. So we need a point and slope of this one. What is that? F prime 2, right?
Yeah.
Okay, f prime 2. That is the slope of at x equal to. And the point is we're gonna find when x is 2, what is the g, right? Okay, now let's find the point. First, find a point. The point, that is a tangent point, okay? Find the tangent point. Point of a tangent or tangent point. This point is a tangent point, okay?
Yeah.
X is 2 already, we know that we're gonna find the y over here. Put this number. This is the value of y, g over 2, isn't it? Okay, when x is 2. Put this number in there. Negative 2 to 2 ft dt. What that means? That is the area under this one from negative 2 to positive 2 up to here.
Yeah.
This area, positive area, because we start from here to the right, that is the negative area. Sum of these two areas is equals to g over 2, right? Now let's find the area of this one. This is the base is 1 minus 2 is 3, the height is 4. The area of this one, base times height and divided by 2 is 6. This is the area for this first triangle. Second triangle is below the x-axis, it's going to be negative area. This area up to 2 over here, 1 to 3, that is equals to 1. Length is 1. Down over here, length is still 2, right?
Yeah.
But this is going to be negative area. We put the negative sign there. 1 times 2, this one is 1 times 2 and divided by 2 equals to 1. But it's going to be negative 1, right?
Yeah.
Up to here, that's enough because what? X is 2, right? Up to here. This is the value of g over 2. How much is that? 6 plus negative 1, okay? 6 minus 1 equals to 5. So this point is now, when x is 2, y is 5, okay? Now we're going to find the derivative. G prime, oh, this is G prime, not F. So we're going to find G prime X. D prime X, this is the dxd, that is the dxd, right? But this one, this is gx over here. Put this number in there. Negative 2 and x ft dt. These are definitions. When you take an integral, but this one is already function of x, right? Because this is t, when the antiderivative, we can put this number negative 2 and x. So x is a variable, still this is now function of x. After that, we take a derivative with respect to x again. By the rule, it what is it? X is a move into the t, right? F of x, that's it. That's the rule, isn't it?
Yeah.
So g prime x is f of x. This is f of x. This is also a g prime x. Same graph. So we're gonna find the g prime 2. Where g prime 2 is what? F over 2, right? F over 2, where is it? Here. F over 2, y is what? Negative 2, isn't it?
Yeah.
That's right. So g over 2, that is f over 2, same thing, equals what? Negative 2, right?
Yeah.
That's the slope equals. G equals m equals negative 2. Now set up the equations. Y minus y1, y minus y1 is 5. Slope is negative 2. X minus x1 is 2. But we don't have this one. They are all slope intercept form. So we're gonna transform, okay? Transform the equation into the what? Slope and intercept form. Negative 2x, negative 2 times negative positive 4, we still have a plus 5. So y equals negative 2x and plus 9 is the answer, okay?
Yeah.
Choice C is the answer. Okay, I'll give you a minute, okay? And figure out. But hold the recording. Find the asymptote of the graph. Y equals 1 plus e to the x, 1 minus e to the x. When you have a rational polynomial function, okay? Polynomial. When you have this one, okay? For example, x squared minus 1 over x cubed plus 2x plus maybe 3 over here. This is a polynomial. Denominator also polynomial. In this case, asymptote, especially right, the horizontal asymptote at the end of a graph, to the right hand side, to the left hand side, always they approach the same line. Okay, when you're polynomial. But now we have e to the x, so you don't have to check both sides. X to the part of infinity. Okay, so if this is q of x, so q of x, that is the limit value at the end of a graph. Okay, you don't have to check a plus minus, only one side is enough. But if this is not polynomial, we have to check right both sides, because e to the x is not polynomial. Okay, if not polynomial, we have to check both. Looks like this one. X go to positive infinity, 1 plus e to the x over 1 minus e to the x. The second one is x go to negative infinity, 1 plus e to the x and 1 minus e to the x. We have to check both sides. Okay? Now check it out, okay, x go to infinite. Okay, you can get to this one. To infinite, shortcut is what is that? E to the x, negative e to the 1 is nothing, okay? So just for e to the x over negative e to the x. How much? Negative 1, isn't it?
Yeah.
So y equals negative 1, right? At the end of a graph, the approach is negative 1 there, this number. The other one is x when x go to a negative infinity, okay? Put this number, negative infinity, check it out. Negative infinity, when you cancel out, what you got? E to the x, negative e to the x, that's it? No, it's not, okay? You gotta be careful. Negative infinity means what is there? Put this number negative infinity, okay? 1 plus e to the negative infinity, put this number there. 1 minus e to the negative infinity. What is e to the negative infinity? 1 over e to the infinity, isn't it? That is 0, right? This is 0, not this one, okay? Are you okay with this?
Then what's the answer?
1 over 1 is 1, right?
Oh. So that one equals 1,
Yeah,
not 0.
this is 1 over 1. To the right is what? Close this one. To the left is what? Close. To the right is what? Close this one. To the left, right, the other side. Looks like close this one, looks like this way. Okay? And the other one is what? To the left, right, up to the negative one, close. Okay, positive one, close, okay? Something like this. Are you okay with this?
Yeah.
So, find the asymptote. So we have two asymptotes, right? Two horizontal asymptotes, not only one. This is not polynomial, okay? So y equals 1, y equals negative 1, okay? Another one is the vertical asymptote when denominator is 0. 1 minus e to the x equals 0. For what value of x that is equals to 0? 1 equals e to the x, right? This is the vertical asymptote.
Yeah.
Denominator. So x equals what? 0, isn't it?
Yeah.
So that is a vertical asymptote over here. Okay? So another vertical asymptote. We have two horizontal asymptotes at this point. One vertical asymptote. I'm going to show you the graph over here, okay? That might be understand. This is y equals 1 plus e to the x Yeah, that's working. E to the x over 1 minus e to the x, 1 minus e to the x. That's the graph. Can you stop here?
Yeah.
There's the vertical asymptote at x equals 0, right? I'm going to provide vertical asymptote. X equals 0. That's the vertical asymptote. To the left, where you go? To the left is what? They close what? Approaches y equals 1 there, okay? To the left. Is it
Yeah.
okay? To
Yeah.
the left. Over here, y equals 1 to the left. But to the right is what is that? They approaches y equals negative 1, okay? Y equals negative 1. We have two different horizontal asymptotes there, okay?
Okay.
Yeah. Because this is not polynomial, right? Exponential functions. Always we have to check right both two sides, from positive side and from negative infinite side.
Yeah.
Are you okay with this? That's why we have two horizontal asymptotes over here, okay? But
Yeah.
still only one vertical asymptote, okay? So choice E is the answer, okay? Okay, just figure out this one more time. So, number 21, let f be the function defined by f of x given by the equation out there. What are the x coordinates of point of inflections? Point of inflections without using calculator, we have to use check out always y f prime x, okay, is 0. You know, okay? But at this point of x, okay, their change, right, concavity, right? We have to check it out. Change their concavity, okay? Okay, first prime over here. 6 move down, 6 times 1 over 20 is what? 1 over 5, x to the 5. Second one is what? 4 moving down, 4 over 12 is 1/3, x to the cube and plus 1. That's the first prime. Second prime over here. Second derivative is what is that? 5 move down there, yeah. 5 times 1 over 5 is 1, x to the 4. 3 times 1/3 is 1, x to the square. That is a constant 0. So this is the graph. You can factor this one. X squared minus 1, okay? Can you go a little more factor over here? X plus 1, x minus 1. That is the second derivative. So we're going to check right there, changing concavity. Maybe better use the graph over here. Okay, this is the graph of the second derivative. They're going to pass by x equals 0 and x equals 1, x equals negative 1, right? The graph is when x goes right infinite, y go to infinite. We start from here. But this is multiples 2 means what? At this point x equals 0, the graph will be bounced. Or other one is what? Pass. This is pass, this is bounced, pass. That's the graph of y equals second prime x, okay? Now check out their concavity. This is positive, concave up, concave down. Yeah, this point is inflection point. This is concave down, another concave down, that is not inflection point. Concave down, concave up, they change their concavity. This is inflection point. We have two inflection point. When x equals 0, there is no inflection point, okay? So
Yeah.
1, negative 1, and 1 only, okay? Okay, try to figure out this one, okay? A particle moves along a straight line. The graph of particle's positions xt is shown above for 0 to up to 8.5. The graph has a point of inflection, and this is a point of inflection, right? Concave down, concave up, right? That's right. For what value of t, the velocity of particle decreasing? Okay, velocity of particle decreasing. We're gonna find, okay, velocity. They don't asking you a velocity is positive or negative. Just we're gonna check it out. The velocity of the particle is decreasing. Okay, That's not asking you velocity is positive. Velocity positive means what? The particle move to the right. Velocity is negative means what? Move to the left. Alright? But this is just what? Velocity is decreasing. Are you okay with this?
Yeah.
Okay. What is the velocity? This is the position. This is a position function, okay, xt. What is the velocity? Velocity is what? Derivative of position function, right? Velocity equals to x prime t, isn't it?
Yeah.
Okay, we know this one. But actually, this velocity is what? Actually slope of xt, right?
Yeah.
That's a slope over here. Slope is what? Very steepy, right? The next is talking about another point of it. Slope is getting down, right? That is decreasing, isn't it? Maybe you can prove it. Slope is looks like this is 8. Getting down, you can use 6. Getting down, slope is 0 over here, right? That is decreasing. Over here. Slope, you can take this negative 5. The next one is what? Negative 6. Are you okay with this?
Yeah.
Right? Negative 7. Okay, very faster, but after this is gonna be what? Concave up there. The next one is slope is what is that? What is that? Getting what?
Up. Down.
Increasing or decreasing?
Decreasing. Oh wait, increasing. Sorry. Yeah.
Maybe you can use it. This slope is what? Negative 7. This slope is negative 5, isn't it?
Yeah.
Slope is over here, right? You can
decreasing.
use some number. Very negative slope is 7, very steepy. 5 is over here, right? Okay. But after this point, negative 7 and negative 5, which number is greater? This number is greater, okay? Negative 5 is greater than negative 7, isn't it? Right? So velocity is what? Increasing, right? Velocity is increasing. Are you okay with this?
Yeah.
Negative 7, okay? We start from 8, 6, 0, negative 5, negative 6, negative 7. The next is a negative 5 again, negative 4 again. From here to here, they are always decreasing. From after this point, they are increasing, right?
Yeah.
Because we know that this is less than. But this is what? Greater, right? So from here to that is greater. So negative 3, not 0, positive 1, positive 2, positive 3. From here to here, all the what? Velocity is increasing, right? Okay?
Yeah.
So velocity decreasing is from 0 to this point, inflection point 3.5. Are you okay with this? So choice digit answer, okay? Because there it's not asking you, not asking velocity is positive or negative. Just what they're asking you. Velocity is increasing or decreasing, okay?
Yeah.
But this time it is what? Decreasing. So from here to here, you can see that number of decreasing, right? 8, 6, 0, negative 5, negative 6, negative 7, decreasing, isn't it? Right after 3.5, that is increasing again, right?
Yeah.
They change from negative 7, they change to negative 5. Negative 5 is greater than negative 7. That's right? Okay, don't be confused over here, okay? So choice D is the answer. Okay, figure out this one more time. Okay, using the slope of tangent. Okay, we can see that velocity is increasing or decreasing. Okay. Okay, figure out one more times. Okay, I'm gonna hold your recording. All right, if you done, okay, you let me know. Okay. Okay, you're good, right?
Yeah.
Okay. Number 23. Number 23, the graph of f prime, the derivative of f is shown above. That is the graph of derivative. Okay. Yeah, negative 4 to 8. For what value of x? The graph of f is concave upward. Concave upward means what is it? Second derivative is positive, right? Also, you can see that graph is what? Upward. This is not original graph. This is concave down. No, this is f prime x. Okay, that is the
Yeah.
graph of f prime x, not original. If this is original, from here to here concave down, and this one all the way up here, that is concave up, right? If this is original function means y equal f of x graph. That's true, but this is f prime x. Okay,
Yeah.
so that is not concave down over here, right? F prime x give us only what? Increasing and decreasing. Minus is what? From negative 4 to this point, the graph is decreasing. Actually, the graph is decreasing down, right? Okay. This one over here increasing. Here decreasing again. Here is increasing again. Are you okay with this?
Yeah.
But we know that second prime x is what? Derivative of first prime. That means what? Slope of tangent to f prime x is the second prime. Are you okay with this?
Yeah.
Okay, where is the second prime there? Slope of this one is the second prime. Slope is what is there? Positive slope, right?
Yeah.
Slope is positive. Here is positive. Here is positive. Here is positive. What is this? Slope of this second derivative is positive. Concave up here, right? Up to here, concave up. Up to here, there is concave up, right? Slope is positive.
Yes.
Okay. Slope of f prime x is what? 0, negative 4 to 2. That slope is positive. That is concave up, right? Not concave down. F is the slope of this one negative number. That is what? Negative is what? Second prime is less than 0. Concave down, right?
Yeah.
Concave down over here. Concave down. But over here, right, just right after number 5 there, right after 5, slope is positive again, right?
Mhm.
Slope is positive means what? Concave up here. This is also concave up. Are you okay with this? From
Yeah.
here to here, that is concave down. Okay? So I'm going to show you the graph of this one, okay, of f of x, okay, approximately, okay? So just give me 1 second over here. I'm going to explain the graph of this one, okay? We start from here, right? Any point. I'm going to this one, any point. Decreasing over here, right?
Yeah.
Up to 2.5. That is decreasing. How do they decreasing? Concave up decreasing, right?
Yeah.
Concave up decreasing this way. Concave up decreasing. Are you okay with this?
Mhm.
All right. The next one is still concave up, but this time is what? Increasing. Are you okay with this?
Yeah.
Concave up increasing up to here. From here, right? Concave up increasing is what? This is concave up increasing. Are you okay with this?
Yeah.
This is concave up increasing, right?
Mhm.
This is concave up decreasing. Are you okay? Still concave up, right? Right after this one, still positive, increasing again. up to this point, still positive. How do they increase? Concave down increasing, right? Concave down increase this way. Concave down increasing, still increasing because this is a positive. Right after this point is 3, they are negative. That is decrease, right? The slope of this one is a negative. That is concave down decrease, right? Concave down decreasing up to here. Concave down decreasing. Are you okay with this? Right after this one, that is still decreasing, right? Okay? After this, still decreasing, but concave up decreasing, right? Up to here, right? Concave up decreasing means what? This way. Okay? Still decreasing, but it's gonna be concave up decreasing. I'm gonna write down. Concave up decreasing. Okay?
Yeah.
Right after this point, what happened? Right after this point, what happened? Still increasing, okay?
Yeah.
But slope is what? Positive, right? Second prime is positive. Concave up, increasing, okay? Concave up, increasing all the way down. That's it. Okay, this is the original graph, okay? This is original graph. Y equals f of x. Okay, from this original now we can see that for which interval it has concave up. From here to here, concave up. From here to here, another concave up. From here to here, there is a concave down, right?
Yes.
So where is it? From here, negative 4 to 2, right? Negative 4 to 2 is a concave up. Another 5 to 8, okay? Concave up. Are you okay with this? From here to also concave up, right? So choice D is the answer, okay? This is the original graph. This one is the graph of a first derivative. Totally different. That's right? Very different, right? First derivative will give us only what? Decreasing, increasing. And also we can find the slope of first derivative is the second derivative, okay? So how do they increasing, how do they decreasing, okay? We can get the information, okay? Okay, figure out the number 23, okay? I'll give you a minute. All right, number 24. After this, we'll finish our lesson today, okay?
Okay.
All right, number 24, take a look. We have differential equations. dy over dx equal 2x plus 1 over y. In high school, differential equations only what? Available for separation, okay? Yeah, this equation is separable. Y to the y, x to the x. Totally separable, right? So dx is what? To move to the right, times dx both sides. We have this one. dy equals 2x plus 1 over y dx. We still have a y there, okay? This one move to the right, left. Times y, times y. Okay, we got this one. Times y as out. So I'm going to write one more time. So y dy equals 2x plus 1 and times dy. That is a complete right, separating. Okay?
Yeah.
This is we said separable, okay? Always we have this one. Fy dy and the g of x dx. If you have this form, that is we said separable, okay? Now this number integrate. Okay? Now y dy, we know the antiderivative is y squared over 2, isn't it?
Yeah.
Okay, 2x plus 1 antiderivative is what? X squared plus x. Are you okay with this?
Yeah.
And we're gonna use by some constant c, okay, to find the initial conditions there. By this point, you can find the initial conditions right away. It doesn't matter, okay? When y is 2, when x is 2, y is a negative 4, right? Okay, put this number negative, y is a negative 4. What is that? Or right after this, we can use this one, but I'm gonna find out, okay? When y is a negative 4, put this number negative 4 then. Negative 4 squared is 16 over 2 is 8. When x is 2 is what? 4 plus 2 plus 6, right? So
Yeah.
this is 6 equals 2, isn't it? So this is 2, right? So you got this one. Y squared over 2 is exactly equals to x squared plus x plus 2, right?
Yeah.
Now we're going to express y in terms of x. Times to both sides, we got this one. X squared is what? 2x squared plus 2x plus 4. So y is plus minus square root 2x squared and plus 2x plus 4. But when you plus minus, we can take out both? No, we can't. We have to check out the initial condition one more time. When x is 2, y is negative 4, right?
Yeah.
When x is 2, or we receive y equal negative, it can be positive, okay? When we put this number, x is 2 there. That is 8 plus 4 plus 4, right?
Yeah.
That is what? Square root 16, 4, isn't it? But it should be negative 4. But you cannot take a positive, okay? So the equation is we take only negative side. Negative square root 2x squared and 2x plus 4 is the equation of y, okay?
Yeah.
So we have an answer over here, okay?
Yeah.
Okay, figure out this one, okay? After you completely understand this one, you let me know, okay?